endocrine glands. The most important and the most difficult is for me is the hypophysis. Hypophysis is a gland which is located near the hypothalamus, near the brain, in sella turcica. Do you remember something about sella turcica? It's the central portion of senate bone. Yes. And in the center of sella turcica, fossa hypophysialis is present. But when the brain is located inside, brain is covered by some tunice, and dura mater forms diaphragma cella in the region of sella turcica and separate hypophysis from the brain as whole. Between hypophysis and brain or hypothalamus is located infundibulum. Infundibulum is the layer of nerve tissue which communicate hypophysis and hypothalamus. That's why very often you will hear about hypothalamo-hypophyseal system, not about hypophysis separately, as a system. Hypophysis has two main lobes. Anterior lobe is called adenohypophysis and posterior lobe is called neurohypophysis. Adenohypophysis is formed or is developed from the ectoderm of oral pocket during fetal period. Neurohypophysis is developed from the nerve tissue, from the neuroectoderm. And these two portions of hypophysis has different function, different the sources of development and different function. Adenohypophysis produces tropic hormones. Tropic, what does it mean? These hormones control different endocrine glands. Thyrotropic hormone controls thyroid gland. Adenocorticotropic hormone controls cortex of suprarenal gland, and so on. Adenohypophysis produced four main tropic hormones. Somatotropic hormone. These hormones control the growth of all organisms whole. Thyrotropic hormone controls function of thyroid gland. Adenocorticotropic hormone controls function of suprarenal gland, cortex part of suprarenal gland. And gonadotropic hormones, there are three main hormones of this group, controls function of the gonads. Gonadotropic hormone, there are three hormones: prolactin, luteinotropin hormone, and follicular stimulase hormone. Follicular stimulase hormone controls follicular cells in ovarium and cells which produce testosterone in testes. Well, prolactin in female organism controls the function of mammary gland. In male organism controls the function of spermatozoa genesis. And prolactin controls in male spermatozoa, in female processes of the lactation. Neurohypophysis. Neurohypophysis is the portion of hypothalamus. And in this portion of hypophysis, hormones don't produce hormones, only run from the hypophysis to blood vessels. Hormones which run through the neurohypophysis is called vasopressin and oxytocin. And these hormones are produced by the nuclei, by the neurons of hypothalamus. There are two main nuclei producing these hormones. Nucleus paraventricularis and nucleus supraopticus. There are nuclei of anterior zone of the hypothalamus. Then these neurons has long axons, and according to the direction of these axons, which forms fascicle bundle, which runs through the infundibulum, these hormones intracellular run to the neurohypophysis, and here run to the blood vessels. Hypothalamus controls function of adenohypophysis by the peptide substances which are produced by the another nuclei of hypothalamus, But these substances run to the adenohypophysis through blood vessels. These peptides, which is called liberins and statins, run to the blood vessels in hypothalamus. Then these vessels forms plexus near the infundibulum and venules which run from the hypothalamus forms capillary network second time, twice. This capillary network is located in the region of adenohypophysis, and from these venous vessels, liberins and statins, which are produced in hypothalamus, run to the cells of adenohypophysis and controls function. For next time, you must study all about hypophysis and hormones of hypophysis. Hormones of the thyroid gland and parathyroid gland. When you will study something about another endocrine gland except hypophysis, you need to know name of gland, name of hormones which are produced here, syntropy, holotopy, skeletotopy of gland. And you need to know the name of main diseases which are developed after increasing or decreasing of the hormone level. For example, thyroid gland. Thyroid gland is the endocrine gland which are located on the level from the 3, 4 to 6 cervical vertebrae. Holotopy is located in midline of the iliac, also in anterior region of the colon, of the regio-colli anterior, sorry, in regio-colli anterior, and syntropy behind of the thyroid gland trachea is located, and parathyroid gland laterally vascular nerve bundle of the neck, upwardly larynx, cartilages of larynx, and forwardly muscle of infrahiatic group and skin. Hormones which are produced by this gland is called triiodtyronin, tetraiodtyronin, thyroxine, and calcitonin. These hormones controls exchange of iod, exchange of all proteins of organism, and hormones of thyroid gland increase catabolism. Catabolism is the process of reducing of proteins. And if the amount of hormones of thyroid gland will be increased, what happened with human? Hypertrophy. Then the temperature will be increased. The rate of the heart contraction will be increased. Pressure, arterial pressure, increase. Catabolismus increase. Weight of the patient less. Many nerve dysfunction may be present. And all these symptoms together is called disease of Bazedi. Bazedi disease. In another variant, in opposite variant, when the amount of hormones decrease less, what happens? Myxedem. Yes, weight increase. Arterial pressure, first of all, less than increase.
Simple goiter.
Yes, you need to know name of hormone, name of disease which may forms. Glands, there are 4 small glands which are located behind the thyroid glands. These glands controls the exchange of calcium and phosphorus in organism. The hormone, main hormone of these glands is called parad hormone. Parad hormone controls the balance of calcium and phosphorus in blood and in the bones. Next gland is located upwardly from the corresponding kidney, skeletotopy on the level of 10, 11 thoracic vertebrae. Syntopy is different on left and right side. On right side near the liver, on left side near the kidney and diaphragm. And inside, suprarenal gland has two types of the substances, cortex and medulla. Cortex has the mesoderm development. The source of the cortex is mesoderm. Medulla is forms from the neuroectoderm, the same as neurodipophysis, and the same as chromaffin corpuses, which is located near the bifurcation of big vessel and controls the arterial pressure in the big vessels. That's why medulla is the same as nerve tissue. And medulla of the suprarenal glands produce noradrenaline and acetylcholine as the mediators of the nerve system. Cortex has three layers and produces three groups of hormones. More superficial layer produces glycocorticoids. Mineralocorticoids. Mineralocorticoids control the level of the minerals such as natrium, kalium, and controls the volume of the liquid in our organism. That's why it controls the pressure. Between the volume of the liquid, controls the pressure. The name of this hormone aldosterone. Aldosterone or antidiuretic hormone. Middle layer of cortex produce corticosteroids or glucocorticoids. It's the name of the same group. Cortisol, corticosterone, and so on. These hormones are called anabolics or steroid hormones. These hormones increase the anabolism processes and controls exchange of proteins, exchange of lipids, and hepatocytes. And inner layer of the cortex of the suprarenal glands control the hormones, produce androgens and produce estrogens. Androgens and estrogens are present in both types of organism, in male and in female. In female organism present androgens, which are produced by the suprarenal gland, and in male organism present estrogens, which are produced by the same region of the suprarenal gland. For next time, you need to study all endocrine glands with name of hormones, name of diseases, and you need to study what types of the exchanging of substances controls this or another hormone. It's a very big topic, not so difficult, but very big. Yes.